Hi, I'm Christopher, a research software engineer with Research Software Workshops, and it's a very warm welcome to Introduction to Data Analysis in our Part 6. Now I have the link at the bottom of the screen here, and we're moving on to the plotting data section, which should look something like this. Now plotting of data in modern R is handled by the ggplot2 package, which is installed as part of the tidyverse. There is an excellent cheat sheet linked here and a great free online book called ggplot2 Elegant Graphics for Data Analysis, which is available, which goes into a lot of detail about how to use ggplot2 and to draw the graphs that you want. Now we could not possibly cover all of ggplot2 in this workshop, so you are strongly encouraged to read the book and the cheat sheet. For today, we're going to give a quick overview of just the idea of how you use this to create some simple graphs. So we're going to be loading the tidyverse as we did normally, so let's do File, New R Notebook, and I'm going to clear the boilerplate. I'm going to save this as, let's call this graphs.r markdown notebook. So first thing, as always, we're going to load the tidyverse. There we are, excellent. Now, plotting, ggplot, like a lot of the tidy functions, is just based on the idea that you're working with already tidy data. So we must tidy up that, say, temperature data that we were using before. So I'm going to copy in the same commands we developed in the last few parts, which are here, which are effectively loading up our temperature data and then cleaning it up so we have nice tidy data, which we can then put into ggplot2. So that's now run. We've now loaded the data up. Now let's draw our first graph, and then I'll explain exactly how this is working. So we draw a graph by using the ggplot function. And what you do is you first pass in the tibble containing the data that you want to graph. The second argument is called the aesthetic, and the aesthetic is how you're deciding how things should be graphed. So for example, which columns are linked to which axes on the graph and what colors should be used, etc. So in this case, we use an aesthetic where we're going to say X. The X column is going to come from the year column in the table, and the Y column in the graph is going to come from the temperature column and the table. And then the final thing we need to add in is actually how are we going to draw the data, and this is called a layer. And there are many functions for drawing data layers, and many of them start with geom, and geomPoint, you can see them all popping up here in the help, is the layer which is used, the function which is used to generate a scatter plot layer. So if I run this now, there we are. There are some missing, I think because I hadn't put my NA values in. Oh, I did have the NA values, interesting. But you can see here, actually probably missing from the beginning of the dataset. Here is the graph, the scatter plot of all of the temperatures which are in this piece of data. Now, as I said, this command has drawn the scatter plot of the data contained within the historical temperature tibble, and it's put the year column on the x-axis and the temperature column on the y-axis. Now, ggplot is written to follow a specific, what's called a grammar of visualization, and there are three components to this grammar. So if we just have a look here, so you can see this more clearly, the generic way that we write a graph is we say ggplot, where we first have the data, so the tibble that contains the data. We then have the aesthetic, which is how we map variables to visual properties of the graph, like temperature went on the x-axis, or we might decide how things are going to be coloured or shaped, etc. And then there are multiple layers, one or more layers, which are how you render every observation. So every visible temperature, every thing in the data, which is an observation. And you can have as many layers as you wish. So in this case, we had, if we go back to this, ggplot, our data was historical temperature, the tibble, and our aesthetic was year goes on the x-axis and temperature goes on the y-axis. And we added one layer, which was a scatter point plot of all of the variables, the values of the individual temperatures. Now there are other geoms as well. We could have used geomLine. Let's see what this does. You can see that we're drawing a line plot. There are many geom functions available, and again, you can find those all in the book that we link to. There are many. It's got to have fun, play with lots of different graphs. Now you can combine the analysis with the plotting. So you don't need to analyse first and then plot. You can merge these two things together. So let's imagine now what I wanted to plot, instead of just the temperatures themselves, I wanted to plot the mean temperature of every single year. Well, let's take our ggplot. So we need to pass in first the data. So the analysis is going to be analysing the data that is going in. So in this case, we're going to take our historical temperature, and then we'll perform the analysis. So we're going to pass this through, first grouping it by year, just as we did before in the last part, and then summarising, where we're going to put a new column called temperature is equal to the mean of the temperature in the initial set, in the initial tibble. Okay, so the data that's going to be visualised will be the result of this analysis. We now need to choose the aesthetic with which we wish to then render the plot this data. So the aesthetic is going to be, well, we're going to have X is from the year column again, and then our mean temperature has been placed in a column called temperature, so Y is equal to temperature. And now we've done this, we now finally need to add a layer. We used geom point before because there were lots of points, but in this case we're going to have many fewer points, so perhaps geom line will work best. So there we have one layer of geom line. If we plot this, here we can see we've now got the line graph, and you can see the temperature slightly going up. Now we can add more layers to this graph just by adding them on. So to geom line, there's another one which is called GeomSmooth. And what GeomSmooth does is it will actually draw a smooth line with a little bit of an error bar. There we are, it might take a little bit of time, but there we are in a nice graph now, where we have the lines, but also we then have the trend effectively showing us what's happening. Now we could do more. Now, for example, let's add a new variable, a new column to the data that is the decade in which the observation took place. Now we can do that by saying we're going to create a new column called decade, and this is going to be assigned from historical column, historical temperature year. Now if I want to get the decade from the year, I need to do integer division, which is this symbol means integer division, and if we divide it by 10, that will give the remainder from dividing by 10. So 1655 integer division 10 will give 165, and if we then multiply that value by 10, that will give you 1650, thus telling us that 1655 was in the decade 1650. Now that we have this decade, and indeed I'll just show you what that looks like so you can be sure that that has actually worked. It's always good to double check things by eye when you can. You can see there we are, we have the decade column set up. All of the rows, there are a large number of rows. It's not even showing all of them in here. This is also why graphing is good, it lets us see all of the data. What we can now do is we can now group by decade and plot by decade. So let's do ggplot historical temperature, but this time we're now going to group by decade. Now we're going to summarise the average decadal temperature, so temperature equals mean temperature, as we have here. And then the aesthetic is going to be, again, not x equals year, because now we're going to look at the decade column, so x is going to be the decade column, y is still going to be the temperature. If I can spell temperature, that is. There we are. And I'm going to draw a line graph now, because that makes more sense. Let's see what that looks like. There we are, we can now see the average decadal temperature. Now, the line chart in this case is not really a good choice for this plot, as it doesn't really show the underlying statistics of this average. Instead, we could maybe go for a box and whisker plot or a violin plot. So to do this, we need to specify the grouping within the aesthetic. So here I've done my group by decade at this point, but actually what I want to do now is let's remove this analysis. and put the group by into the aesthetic itself. So it's saying group the data by decade. And now when we plot, rather than doing a geom line, we can do a geom violin to draw a violin plot. So now what's happened is it's drawn all of the data that we had, but now it's grouped by decades. You can see every single decade's values have now been put into a violin plot. Now this is okay, but what we could do is we really want to smooth the data as well and draw a smooth line. So the aesthetic of grouping can be passed here once within the actual geom plot, but sometimes you want to have different aesthetics for different parts of the graph. And so you can place a default aesthetic, which is the first part. So here, so by default, everything is going to x is year in this case, and y equals temperature. But then for violin, we want an extra part added to the aesthetics. We pass it an extra part here, saying that when we draw the violin plot, you should add the aesthetic of the group is equal to the decade. Now, why are we doing this? We're doing this because what we'd like to do is now also draw a smooth line for the years as well. So if we now do GeomSmooth at the same time and add that on, GeomSmooth will work with the aesthetic of x is year, y is temperature, whereas Geom Violin will work with the aesthetic x is year, y is temperature, but draw the violin using groups of decade. And there you can see we've got this plot here. We can see the temperature, average temperature slowly rising from the 16th to 21st centuries, but also the spread of the temperature as a violin plot, showing how it's changes in the minimum temperature moving upwards, which seems to be having most of this impact on this average. Now the next question you might have with graphs is, it's nice to be able to put these graphs into an R Markdown notebook, but how can you save it to maybe a PDF file? To do that, you would use the ggSave function. And what the ggSave function does is it will save the last generated graph to a file. So if I do ggSave violin.pdf, you need to pass in the file name is the file you wish to save it to. Device is then the file format we're using. So in this case, we're going to be saving it as a PDF file. And then the DPI is the resolution. And generally you want to save things for publication using print, which will save it with quite a high resolution. So if I run this, there we are, it's now run and it's now saved it, and it's actually gone into my home folder, which is here. And if we now look, it's called violin. So let's go to the bottom. There we are, violin.pdf. Wonderful little PDF file there. Okay, so that's now walked you through all of the plotting section, just a really quick sort of demonstration of what ggplot can do. And we're now at an exercise where what I'd like you to do is to create a graph that shows the average maximum temperature by month. Now draw this as a line graph, and you may need to use group by decade to the aesthetic so that the line layer can join together the points. Then I want you to create a graph that shows the change in average temperature in December per decade. Draw this as a scatter plot with a smooth trend line added. And then finally, I want you to create a graph that shows the change in average temperature by century. Draw this as a line graph with a smooth trend line added. And note that you may need to adjust the span value if the number of data points is too few to draw a very smooth line. And again, press pause. And when you come back from pause, I'll show the answer. And for this, don't feel free to peek at the answer beforehand, because this is quite a complicated exercise. Okay, we've unpaused now, so I'm going to take you through the answer. So I'm going to just clear these parts and just take us back to the point where we've loaded the data and it's now ready to go. So we've loaded the tidyverse, we've loaded the data up, it's now been cleaned and it's now ready for graphing. So we only graph tidy data. Now the first thing we're going to need is to add in the decade and century variables, because we're going to be using them later. So historical decade is what we had in when I was showing up before, and that's where we can say this is going to be the historical temperature, year, integer divided by 10, and then times 10. And then it shouldn't be too much of a surprise that if we want to see century, it's going to be using by 100. So integer divide 100 and then multiply by 100. And indeed, if we have a look at this, just to be sure that we've got this right, there we are, we can see that's in the 1600s, and they're in the 1700s, and this is correct. So the first thing we want is the graph that shows the average maximum temperature per month. So let's go down. R section, I'm going to go ggplot, so it's going to be the historical date temperature, but now let's pass this through a group by, where we're going to group by month because we want the average and maximum temperature per month. And we want to summarize this because we want the maximum, where the max temp column is going to be equal to the maximum temperature, where we make sure that we ignore NA values. And then remember, we have the dot groups equals drop, just to make sure we don't have that error message. And then now we've got the data that we're going to plot, we need an aesthetic. In this case, we're going to be plotting the month. The Y value is going to be that new max temp column that we've created, and then we're going to be grouping it by month. And now finally, what do we want to draw it as? The layer that we want to use. In that case, we're going to use a line graph. So we're going to do geomline. There we are. This is a plot of the average maximum temperature per month grouped by decade. Now the next thing we want to look at is the change in average temperature in December per decade. So the change in average temperature in December per decade. So again, we're going to do a new R block. We're going to say ggplot. So in this case, we're going to take historical temperature. I'm going to pass this through a filter because now we only want the months of December. Then we're going to pass this through a group by, it's going to group it by decade. And then we're going to summarize it now, where we're going to say the average is going to be, the average column is going to be the mean temperature, where again we ignore the null values, the NA values, groups equals drop because we don't want that particular error message to come out. And now that we've got the data that we wish, we're going to use the aesthetic, where we plot decade on the X column, and on the Y column we've calculated this average. And then what do we want to plot here? How are we going to draw it? Well, let's do it as a scatter plot, and then also with a smooth line as well. There we are. So this is now showing us, don't worry too much about those error messages. This is now showing the change in the average temperature in December grouped by decade. So it's basically averaging every single decade's December values together and then plotting them, as you can see here with the smooth line, which is showing us the trend. Now the next thing we wanted was a change in the average temperature per century plus a smooth trend line. So again, let's now plot this in. So we're going to create a new R block. Okay, ggplot again. So historical temperature. We're going to now pass this through now a grouping by century. Now we want to summarize, where we're going to calculate the average mean across the century. It's going to be the mean temperature, and again we don't want any of the NA values, and we can drop the groups. Now that we've calculated the average temperature per century, we now want to plot that onto a graph where the aesthetic is the century is now on the x-axis. And on the y-axis is that average that we've just calculated. And then we're going to plot this as a scatter plot. And then if I do GeomSmooth, what we'll see is it won't look quite right. And indeed, you can see we say the span is too small. It's very difficult for it to calculate an average or a span because you can see we only have here 1, 2, 3, 4, 5 data points because we only have 5 centuries. In this case, we're going to set a smaller span, and you can look into the documentation to see what span does. And by doing that, it now kind of sort of creates a smooth trend line with some error bars that looks a little bit more realistic. Okay, so that's now answered all of the parts of this exercise. So we've now been all the way through this. We've now reached the end of this particular part of the workshop. And so on to the next video, which will be the final part of the workshop where we provide a summary. I look forward to seeing you there.